All right, so we've gone over Earth's history, looking at 8 and 9 of the reference table. We've looked at uh, rock layers or rock strata. Now we're going to start looking at index fossils. So here's a question. How do you match up all of those rock layers around the Earth with each other? To begin to answer that question, you need to figure out how old the rock layers are. Okay, so you need to start with an index fossil. A regular fossil is the remains of a creature that lived long, long ago, right? Usually that's what a fossil is. Usually the skeletal remains, the bones, or an imprint in the rock of a plant or an animal. It could even be feces left over from like dinosaurs or something like that. There's the shells left over from any shelly animal. With the possibility of dozens or hundreds of fossils in each rock layer that you're looking in. When that happens, so you have all these things, say you're at a beach, or what was a beach area, there's so many fossils right there. How do you determine things? Well, what happens is you want to look for one special fossil, and this fossil is called an index fossil, and it is different. So index fossil, the things that are required with them, there are three things. First of which is they are spread out over the whole world or a very, very, very large area. Like Syracuse, New York would not be large enough, but the state of New York would be large enough. You want a huge, huge, huge area. A second thing that you want to look for in an index fossil is that it existed for geologically a short period of time. So if you see multiple layers, like different layers in the strata, the rock layers, with these animals or these fossils in it, that means that they existed over a long period of time. You want it for one rock layer, just it. That's like one rock layer only. So looking at this diagram above, what would make a good index fossil? Well, the first thing I would do is I would look over here. We've got the trilobite. All right, so there's one here. There's none over here. So I don't think it'd be such a good one because you want them in both sites because that's the large area. Remember, you want large area, short time. And I did say there were three things. So the third thing we're looking at, and it's just kind of like an obvious thing. They have to be easily identifiable. So all of these are easily identifiable. So they potentially could all be index fossils. The trilobite was on one section. You need them to be in all the sections you see or all the sites or outcrops, but there's only one here. So it can't be. You can't have it as an index fossil. All right, let's look at this, the ammonite. All right, well, the ammonite automatically gets crossed out because I've got two layers right here. You only want one layer, so it can't be the ammonite. Let's go up. We've got this shell right here, and it's the only one over here. Okay, good. Oh, there's one shell right there. That's perfect. That's an index fossil. Are there any more? Well, there's a fish. No fish up here, no fish down there. Ooh, there's a fish right there. Ooh, the fish is a good one. That's another good index fossil. We have this layer. We have that. We're not going to look at that. Ooh, feet prints. Oh, but there's two of them. So no go for that. Oh, we've got leaves. No go for that either. Let's see. Leaves, footprints, feathers. Oh, we can't do feathers either. How about this? Jawbone. There's a jawbone. All right, there's one there and there's one there. Perfect. So it could be a mammal, a fish, or a shell. Everything else could not be considered an index fossil. Those three could be considered an index fossil. All right, there's another index fossil, but it's not a fossil. It's called volcanic ash. So this is because when volcanoes explode, they last for geologically a short period of time, and nowadays a short period of time. All the while, but even though they're like, well, it exploded over in Hawaii. It's not going to affect us. Actually, it does, because the explosions that go off with these volcanic eruptions, they go up into the atmosphere and in the stratosphere, and they spread out all around the world, and all of that comes back down. And that can form a thin layer of volcanic ash, which makes a beautiful index fossil. Yeah, the whole Earth. All right, so let's look at this set of, let me move me. Index fossils right here. Look carefully at the diagram. Which letter, A, B, C, or D, is the best index found over a large area? All 4 areas, but for a short period of time. Only one section in each layer. Let's look. We've got A. There's one layer. That looks good. I like A. Well, let's keep making sure, let's make sure it's all right. So we have this little finny dude. There's 2 finny dudes, so B can't be it. All right, that shell. Oh, there's a shell there. There's a shell there, but oh, look at that. There's 3 in 1. That's out. Curlicue. No curlicue. No curlicue. No curlicue. 1 curlicue. Can't do it. It's got to be A. All right. So I'm going to combine what we did last time in the last topic, which was identifying what came first, with index fossils, with saying what time period those index fossils came from. So you're going to be using page 8 and 9. All right, so we know that the Manticoris, the Manticoris is the shell, which you'll notice right here. I'm not just coming up with the name all by myself. The Manticoris is right there. That is the shell, letter G in your reference table. If that fossil is a Manticoris, you can then label the rock layers with geological time periods. So we already know how to label or sequence rock layers if it's not overturned, which these are not. And what we're going to do, I'm going to use the first outcrop, right? So because it's all the same, I'm just going to use the first one. You know, this came first, this came second, third, fourth. All right. But we know it's the Manticoris, and we know the sequence. Now we can figure out the geological age. So this is G right here. I'm going to look for the letter G over on page 9 in this nice little section with all the letters. So I'm going to find G, and G is right here in this group. And I'm going to follow that across all the way over here to where it says what time period, and the time period is Devonian. So I know the third one is Devonian. And this is where it gets really simple, because all you got to do is go up and down in your reference table on page 8. So I want to know what layers. You can choose up or down, whatever you want to go. So if this is Devonian, the one above it is going to be Carboniferous. The one below it is Silurian, and the one below that one is Ordovician. So I can label Carboniferous is above. That's Carboniferous according to page 8. And then number 2 is going to be Silurian, and then the bottom one is going to be Ordovician. All right. So we know how to sequence. We know how to find our index fossils. Once we find our index fossils, we look to the very bottom of the reference table, whatever side, and then we find them on page 9 in the time distribution of fossils. And then we're going to open it up, and this is why it's set up like a notebook, is you can follow the line straight across to figure out what time period. And then you just have to go up or down in time periods going along with whatever sequence you're in. All right? If you have any questions, please don't hesitate to ask. And besides that, I hope you have a nice day.